In this video, I will discuss the settings in Cambam that affect the accuracy of the output. There are two different menus in Cambam where you can enter values that I thought might affect the accuracy of the output. One is in the Cambam Options panel, and the other is on the menu for the hypocycloid plugin. What I found was that the variables on the Cambam Option panel had no effect on the output, but the max segments variable on the hypocycloid plugin menu did have an effect on the output. I changed the max segments value in steps from 500 to 10,000 and got some interesting results. This is the options page, and the values I checked out were arc, display degrees, spline to polyline tolerance, and spline curve steps. None of them had any effect on the output. Other than the max segments value, I will leave all of the other values the same for comparison. What I did was generate the cam profile without the pressure angle or offset values, then explode the polyline it generates into a series of arc and line segments. The first thing I noticed was the peaks looked a lot smoother than the valleys, and the segments were not symmetrical on both halves of the peak or valleys. This is what prompted me to investigate the accuracy of the profile. Starting at 500, I will explode, and it generates 500 segments, and the maximum deviation from the reference was 5.7 thousandths of an inch. All the segments that were generated were line segments, and I'll step through a few of them here so you can see what they look like. Now I'll jump up to 1,000 segments. At 1,000 segments, the maximum deviation was 1.8 thousandths of an inch, and it generated 840 segments. And I will explode those. And they were arc and line segments. Most of the arc segments fell along the crossing point of the zero pressure angle. I will step through those so you can see what they look like. Line segments on the peaks, arc at the crossing value, lines in the valley. Now I'll move to 2,000 segments. At 2,000 line segments, it generated 560 segments. Peak were arcs and the valleys were lines. I'll step through those so you can see what they look like. Lines down at the valley, peaks or arcs. And finally, I'll move to 10,000. At 10,000, all the segments were arcs, and there were 360 of them. All arc segments. The only way you can get more accuracy than this is to scale the profile up, generate the profile, and then scale it back down. And what I did was move the decimal place over to the right 2 places to make it 100 times bigger. I generated the profile and then scaled it back down and exploded it. And that gave me 7,920 line segments, and they were arc and line segments. And this is what I used for my reference to compare all the other results to. From these results, it is my opinion that 10,000 is a good number for the max segments value, and that scaling up and then back down is overkill. In the end, the final accuracy of the cam will be affected more by tool deflection, backlash, and vibration than the output of the hypocycloid plugin. The other big factor in the final accuracy is the resolution setting in most cam programs. If you set this too small, it will generate a lot of very small segments, and Mach 3 will choke on them, giving you a jerky or slow feed rate. Next, I will show a visual comparison of the results as viewed in Rhino. Hopefully in some future video, I will compare and analyze profiles generated by other programs and cam profiles edited in Rhino. Here's the results as viewed in Rhino. The first thing you notice is down in the valleys, everything's a lot rougher than at the peaks here. I'll start at 500 and turn on things sequentially as I tested them. There's 500 and 700, 1K, 2K, 10K, and the reference. This is the maximum deviation of the 500 segments, and it is 5.72 thousandths of an inch. Next is 1K, and it had a maximum deviation of 1.8 thousandths. Next is 2K. It had a maximum deviation of 0.4 thousandths of an inch. Next is 10,000, and it had a maximum deviation of 46 millionths of an inch.